Hi, 7th period. I am recording the lesson that I am teaching as I'm teaching it in 2nd period. So hopefully you guys hear everything. I don't think you'll be able to hear what the other students are saying. But follow along to the substitute teacher if you need to pause the video, if the kids need it paused at any point or rewound, please do that for them. Okay guys, 6.3, completing the square. This is another way we are going to learn how to solve quadratics. So how else have we already learned to solve quadratics? Graphing. Factoring. And the way you guys just didn't do is using square roots, right? Okay, you can only use a square root if there's an x squared with no x term, so if there's a quadratic term and no linear term. And then completing the square is the way we're going to learn today. Do you guys remember this from Algebra 1? I know you do. You didn't like it. Hopefully it'll be easier today. All right, so first of all, we need to know what perfect squares are. So what is 2 squared? 4. So 4 is a perfect square because it's 2 squared. 3 squared? Sure. 4 squared. Oh, tricked you. It's 100. 16 squared? Well, gee, if we don't know the answer, how could we find it? The calculator. 256. Yes. Is this going to be a perfect square? No. Absolutely. It's something squared. That's a perfect square. What is this? It is not. X squared plus 9. That is that same mistake that I have told you guys how many times? What is it? Foil it. You have to foil it. Good. Don't miss that middle term. What about this one? 9x squared minus 12x plus 4. Okay? These two things here, those are called perfect square trinomials. And we're going to be working with perfect square trinomials quite a bit here. If we have this equation, how would you solve it? Sure. So if you're trying to get x by itself, we have to go to the square. A square root does that. What must you put into a problem if you insert a square root? Plus or minus. So we have x equals plus or minus 5. 2 solutions. Can we have 2 solutions for a quadratic? Yeah. Absolutely. We could also have how many solutions? 1 or none. What do the solutions of a quadratic actually represent? The zeros. The x-intercepts, also known as the zeros or the roots. Good. How would you solve this one? The shortest way possible. Take the square root of both sides. Don't forget your plus or minus. X plus 4 equals, good. Then what? Okay. Good. So positive 5 minus 4 is 1, and then negative 5 minus 4 is negative 9. We okay with that? Okay. So it's pretty easy to solve an equation that's in this form, right? By taking a square root. What we are going to do is we're going to take other equations that are not in this form and put them in that form. It can be helpful for an equation to contain a perfect square. Why? Because if it does, then you can just take the square root of both sides. If a quadratic expression or equation does not have a perfect square, we can create one, and that is what you're doing when you're completing the square. Another way to say it could be creating the square. That's what you're doing. So if you have these two terms, what number could we add that would create a perfect square trinomial? In other words, we want to get this into the form x plus or minus a number squared. What number C would do that? 4. I'm hearing 4. The C would have to be a 4. Okay? Then in here you would have x plus, is it working? Is it the 4? Is it 4? It's not 4. Can someone shut that door? That didn't work. Try something else. What number would have to be here to get this in the middle? I agree it's 8. What number would have to be here then? What do you end up doing with those 8s? 64, you square it, right? Okay. So here's how you do it. We know that we're in the form ax squared plus bx plus c, right? To find the c, you take b, you divide it by 2, and you square it. That's the number that will complete the square. So in this case, b was what? 16. What's 16 divided by 2? And what is 8 squared? And there's that magic number. Okay? What are you doing from this step after we add the 64? What are we doing from that step to here? What are we doing to get that? You're factoring, right? What you're doing is you're factoring. What multiplies to 64 and adds to 16? 8 and 8. Well, another way to write that would be x plus 8 squared. The shortcut, you don't even have to think about factoring, is if you just take the b divided by 2, that's what goes right here. B divided by 2, 16 divided by 2 is 8. Okay, so let's use those. So for the second one, x squared minus 8x plus c. To find c, we have to take our b. What's our b? Divide it by 2, square it. So the number we need to add on both sides is 16. Then we want to take this new perfect square trinomial and factor it. What would this factor into? Well, the shortcut says it's x, and then you take your b and divide it by 2. So negative 8 divided by 2 is, there you go. Is x minus 4 squared the same as x squared minus 8x plus 16? Absolutely. Okay, so this b divided by 2 squared, that's completing the square, writing it as the perfect square trinomial then. So let's show you how that helps you solve equations now. Solve this quadratic equation by completing the square. When we were factoring or graphing, what did we need our quadratic equation to be equal to? 0. When you are completing the square, it's usually more helpful if it's equal to your constant. So normally we're in the form ax squared plus bx plus c. When we're completing the square, it's actually going to be the best if you're in the form x squared plus bx equals whatever this happens to be. It's not necessarily going to be your c because you're going to do stuff to it. Okay? So we want just the quadratic and the linear term over here, which is what we have. Okay? We have to figure out what we're going to add to make this turn into a perfect square trinomial. The way you find that, you take your b, which is, do what to it? Divide it by 2, which is negative 3, and then do what to that? Square it. What is negative 3 squared? 9. So we are going to add 9. But this is an equation. Whatever you do to one side, do to the other. So we have to add 9 on the other side as well to keep our equation balanced. Is everybody okay with coming up with the plus 9? Okay. Then what you're going to do is you're actually going to write this as the perfect square trinomial. Technically what you are doing is factoring, but you really don't have to think about factoring. You can just take the shortcut, which is to take your b, your original b, and do what with it? Divide it by 2, which is -3. And now we're equal to 49. You're welcome to actually factor it. You can always factor it, do the AC method. What multiplies to 9 adds a -6, -3, and -3, but it's always going to turn out that way. Joe? B by 2. Same first step as finding the number that you're adding. Positive b divided by 2. So -6 in this case divided by 2. Okay? So sometimes, I'll wait a slide until I say that. All right, so now that we have it in this form, the advantage is you can solve it relatively easy by doing what? Taking the square root. Plus or minus. X minus 3 equals plus or minus. Add 3 on both sides. Positive 7 plus 3 is -7 plus 3 is 2 solutions. How can you check your answers? Plug them in. Plug one in to the original equation, see if it works, then plug the other one in. So this, if we were to graph this, we would know that this crosses at 10 on your x-axis and at -4. Any questions on it? Okay, let's try another one. What should we do first? Good. We want to get just the quadratic and linear terms on one side. So that means we're adding 16 on both sides. Now we're equal to 16. Now what? Good. You need to find the number that's going to turn this into a perfect square trinomial. The way you do that is you take your b divided by 2 and square it. So 6 is our b. Divided by 2 squared is 9. We're adding 9 on both sides. That's what it was last time, wasn't it? Make sure you add it on both sides. What is this perfect square? Good. You have two options there. You can factor this trinomial, just like we were doing in the last section, or you can take the shortcut and remember that it's just your b divided by 2. Goes right there. Equals 25. All right, now at some point every year I have students ask me, if we're just going to end up going here, if we're just going to end up getting this and we're just taking this b and dividing by 2 and putting it right there, why do I have to do this step where I add the 9? Why can't I just go from here to there? What's the answer? Right, the other side. If you don't take this step, you'd still have a 16 right here, and that equation would not be true any longer. You got it out of balance. Okay, so you must have this middle step where you decide what to add so that you remember to add it on the opposite side. From there, it should be solvable with a radical. Don't forget your plus or minus. X plus 3 equals plus or minus 5. Subtract 3. What are your answers? 2 and -8. Check them and make sure they work. We okay with them? Okay, let's do this one. Any questions so far? Does it feel easier than Algebra 1 yet? No? First thing to do. Nice, Connor. You're on it. Subtract the 24. Quadratic and linear term equal to a constant term. Then what? Take b divided by 2 and square it. Unfortunately, it's a what? But we're not scared of fractions, right? Fractions are just numbers. 11 divided by 2 squared is here 25.25. You can do that. You could also leave it as 121 over 4. You guys don't like that, right? You're going to like this, right? Okay. I'm going to keep it like this for a sec. Yeah, I'm going to. All right, so I have a squared plus 11a plus 121 over 4 equals negative 24 plus 121 over 4. Okay, now what's the next step? Okay, so it's a. Does everybody see where he's getting that? What you're doing is factoring this. That's not going to be real fun to factor though, right? Even if you have the 25.25 here. However, remember there's a shortcut. All you have to do is take your b term and divide it by 2. Yes, sir. Is it 30.25? Sorry, 30.25. See, that's why I just like my my fraction. Fractions are better. Is everybody okay with the shortcut? Because I don't want to have to factor that. I don't want to have to factor it in either decimal or fraction form. Take the shortcut. All right, negative 24 plus 121 over 4. What? Anybody else get that? Somebody confirm, is she right? If you're staring at the screen, you're probably not really doing anything right now. 25 over 4. She's right. Now, if you had it in a decimal form, what would that be? Okay, so 25 over 4 is the same as 6.25, and you are welcome to use either form. I don't care if you use fractions or decimals. However, one of them to me is easier, because in the next step, what are you going to do? You're going to do the square root. On the left side, of course, that's a plus 11 over 2. On the right side, I don't need to pick up my calculator if I use a fraction, because I know the square root of 25 is 5 and the square root of 4 is 2. But if I was looking at the square root of 6.25, I honestly wouldn't know that off the top of my head that that's 2.5. Okay? So if you're good with doing some square roots in your head, I would keep it as fractions. If you know you're going to pick up your calculator for every calculation anyway, then it really doesn't matter. Maybe you want to go with decimals then. So it's up to you. I like to work with the fractions because I can do mental math quicker than I can pick my calculator up. In some cases, not all. Okay? Up to you there. Don't forget your plus or minus sign. And then we're going to subtract 11 over 2. Okay, so positive 5 minus 11 is divided by the 2 would be negative 3. Negative 5 minus 11 divided by 2. There's your 2 answers. Many of these problems will end up working with fractions or decimals. If your b is an odd number, you're going to have fractions and decimals. You got to deal with it. So you guys try this one. I'm going to pause the video here, and when you guys are ready, you can hit play. And then at that point, we will start going over the problem. Okay, guys, check out my work. Check out my answer. So if you look up here, the number you had to add on both sides was 49. I did. 49 over 4. Okay, and then this is your perfect square, and we're equal to 33 over 4. We have to take the square root of 33 over 4. There is no perfect square in 33 at all, so that's going to stay under the radical, but we can do the square root of 4, so now it's 2. Be very deliberate about how you write that. So here, I think it was pretty obvious that my 4 was part of the radical. And here now, it is obvious that the 2 is not. So you need to make sure you're writing very neatly so that you can tell what's under the square root versus what is not. Then you need to add 7/2 on both sides. Well, one's under a radical, one isn't, the 33 and the 7, even though they have the same denominator. So you cannot actually combine them. The best you can do is write it all as one fraction, since they have the same denominator, just 7 plus or minus the square root of 33 all over 2. Are we okay with that? Now, if you wanted to know, like if you were actually trying to find the zeros, that is the precise answer. But maybe we don't know what that number is. Like maybe you're doing a word problem and you want to know. So then you would just in your calculator go 7 plus the square root of 33 divided by 2, and it's about 6.4. Okay, so if you're doing a word problem where you need to know something's happening at that y-intercept, you can find the approximate decimal, but the precise answer is given by this. Anybody get it right? Would have? Okay, gotcha. All right, let's try, sure, let's do a fraction one. Let's do this one. You guys want to try it by yourself or together? Try it by yourself? All right, I'm pausing the video again. Try this one on your own. Okay, did you get that 1/4 was the number to add on both sides? Yes? Okay. And that x minus 1/2 is your quantity squared? Yes. Okay. Then we're taking the square root. So we have x minus 1/2 equals plus or minus. Let's do the top. Can you take the square root of 15? No. No. Can you take the square root of 4? Yes. Yes. What about that negative sign? What did you guys learn about negatives under square roots? Oh, you can. We learned how to do it. The I. If you have a square root with a negative underneath it, remember that we have the letter I, the imaginary number. So plus or minus I square root of 15 all over 2. Are you okay with that? Do we see that? If you have a negative under the radical, it's no longer we can't do it. We can do it. There's an I. Remember that I is equal to the square root of -1, which allows us to do that. What else do we need to do? Add 1/2 on both sides. So x equals 1 from here plus or minus I square root of 15 all over 2, since they had the same denominator. Anywhere we need more explanation through there? 15 is -4 plus 1/4 is -15 over 4. And again, if you would rather use the decimal, you can. It's just going to be more difficult when you go to simplify your radical. All right, let's do a hopefully simpler one with an I. Not a fraction, at least. All right, let's do this together. What's the first step? No. Subtract that 29. Get it out of the way. Now find your number to add, your magic C number. What is it? 4 divided by 2 is 2. 2 squared is 4. So we're adding 4 on both sides. Write it as a perfect trinomial. So what is it squared? Good. Shortcut, of course, is take your b, divide it by 2. Equals -25. Then what? Take the square root of both sides. What must you remember on the right side? Before the I? Plus or minus? Okay, so we have x plus 2 equals plus or minus 5i. The square root of the negative is the I. The square root of 25 is the 5. Finish by subtracting 2. So x equals negative 2 plus or minus 5i. There are two solutions there. Remember when we were graphing and we were able to get no solution problems? When you're completing the square, we will never say no solution. These imaginary ones go with graphs like this. Okay? So if you get imaginary numbers and you graph imaginary solutions, if you graph that type of quadratic, it will look like one of these. It won't actually intersect the x-axis. All right, one more. I'm going to give you a challenge problem here before we wrap up. Let's do this one. What's different about this one that wasn't, that is different from all the other problems we've done? There's a coefficient. Okay, so that adds an extra bit of complexity to it. We still want to get it like this. That still is the same. But we now also want to get rid of this 2. How could you get rid of that 2? Divide absolutely everything in the entire problem, both sides, by 2. So now we have x squared minus 11 halves x equals negative 6. So here's more fractions that you will have to deal with. If there is an a term, you must divide everything by a. After that, it's the same. It's just you've got fractions to deal with. What number should we add on both sides? Well, 11 halves divided by 2, which is our first step, is 11 fourths. 11 fourths squared is?
121 over 16.
Could you have just picked up your calculator and did all that? Absolutely. I'm fine with that. Mental math is awesome if you can handle it. Add 121 over 16 on both sides. Factor it or turn it into the perfect square. It would be x good. I don't want to try to factor that. That's not going to be fun. But the shortcut, b divided by 2, negative 11 over 4, equals negative 6 plus 121 over 16 gives you 25 over 16. Pause. Are we okay through there? Do we know where all of the numbers have come from?
Yes.
Okay. So now we should have an equation that is relatively easy to solve. Take the radical of both sides. X minus 11 fourths, because your squared and your square cancel, equals plus or minus. Look how nice this is. What does that become? 5 over 4. Square root of 25 is 5. Square root of 16 is 4. Add 11 fourths on both sides. Okay, common denominator, so add the 5 and the 11, you get divide by 4. Negative 5 plus 11. 6. 6 divided by 4 reduces to 3 over 2. Okay, so if you have a value, you need to divide off by that. Divide everything by that. If you have a negative under the radical, you need to pull an I out. Any questions on this process of completing the square? Super exciting and fun, right? All kinds of good algebra in there. All right, there is your assignment. I'm also going to put up your answers to your homework that you can check from your factoring worksheet. I'll try to split the screen here so you can see both things. If you need to move up to see those better, you may. I don't think I can make it that big.